Hello, welcome to Beginners Python and Machine Learning. My name is Tim Cummings. So we're a regular meetup group where we discuss Python issues and how to help beginners get into Python, and we also look at machine learning. And today we'll be doing a little bit of both. I'm going to be demonstrating how to use a pre-trained machine learning model. So the reason for using a pre-trained model is that training is what takes a lot of time with machine learning and a lot of computer power. So there are some models that have already been trained and we can use them just straight out of the box. You can also fine-tune them a bit yourself, but we're not going to be doing that today. So today we're going to look at a few pre-trained models that are available and try to use them to identify a photo, and you can follow along. You can even try your own photos in this and see how you go. All the code is provided for you. We're going to use Google Colab, so you don't even need to install Python onto your computer. So let's there's a link just below on the video that you're watching on YouTube, or if you're on Meetup, then right down the bottom here I've got the link to Colab. So I suggest you click on that link and take you to Colab. Now if you've got any questions, this is a live stream, so the advantage is you can ask questions as we go along, and I'll be monitoring Slack and there are instructions how to get onto Slack in the Learning to Code channel of Beginners Python and Machine Learning. Beginners Python, it's just called Beginners Python. And I'll also be looking at the YouTube chat, which is this one here, and no one said anything yet. Alright, so let me know if, especially if there's things like the audio is no good or I'm going too fast, but we'll have a go. Now, this is the first week of the month, and we try to target absolute beginners in this. So yeah, any question is not too simple. You can certainly ask them, and I'll do my best to answer them. Alright, so Google Colab, this link has brought it up. You see it says changes will not be saved. That's because you've brought up my version of it, and so I recommend that the first thing you do is make a copy, and there's a button here saying copy to drive. So let's take a copy of that, and that way you can make changes as you go along and save the changes into your own area, and that will you'll have a reference for in the future if you ever need it. Release notes. Okay, so there's a new version of Colab running at the moment. They've upgraded all these Python packages. That looks really good. And if you're subscribing, you can pay for this, but I'm just going to use the free one today. And it looks like they've upgraded some of their GPUs. Alright, we'll close those release notes. We can turn off that message. So the first thing, I've got some links here. That's the link to this Colab notebook. This is the YouTube video. That's the event. And we've also put all of these into GitHub, and so you can download them if you want. And if you look in there, you'll see this will be a Python only version of today's meetup rather than a Python notebook. So you see this ends in .ipynb, which is an interactive Python notebook. And but I've also got a Python one if you don't want to use notebooks. But notebooks are great, so you're probably best to use a notebook for this one. Okay, so our objective is using a pre-trained model. So when you're training a model, it's almost essential to use a GPU, so it's a graphics processing unit, because they're really good at doing massively parallel computations, which is exactly the sort of computations required in training a machine learning model. Once you're using a pre-trained model, the GPU will improve performance, but it's not absolutely necessary. So I think we might try the using a GPU. I've done this without, and it doesn't make a lot of difference. But seeing it's available to us, let's give it a go. So we go up to the runtime menu and select Change Runtime Type. And we want T4 GPU. And of course we want Python. Python, there we go, Python 3. We don't want R or Julia. Okay, latest, and we'll save that. Okay, so now we've got that running. See, it says T4 here, so let's connect in. And so I'll start off, I'll just explain a few terms. Artificial intelligence, I'll just define that. That's the science and engineering of making intelligent machines, especially intelligent computer programs. Now, machine learning, which is what we're doing here, is a branch of artificial intelligence which focuses on the use of data and algorithms to imitate the way humans learn, gradually improving accuracy. Now, a particular form of machine learning we're going to be doing is using neural networks, which mimic the human brain through a set of algorithms, and they're really quite simple. Simple algorithms. It's just a linear equation. So they look at a few inputs, x1, x2, x3, and they apply these weights, w1, w2, w3, to those each of the inputs. They apply a bias, which is just another number, and calculate the output. Now, each set of calculations for this is creates a layer, and then by putting in multiple layers, you can create a more complex model that can actually learn. So you can, using training data, you can guess some values for the weights and the bias and see how close it got, and then you try changing the weights and the biases and just keep changing them until you get to a closer to what the reality is. And that's the way that the algorithm can learn, and it just gets these better weights and biases to give a more accurate answer. So deep learning is when you've got more than 3 layers in a neural network, and I won't go too much into layers that are a bit more complicated, but basically the output from one layer is the input to another layer, and we do a nonlinear transformation just to break this linear pattern that we've got. Otherwise you could just do it all in one layer, but we need some sort of thing to happen. Anyway, GPUs are good for that, for training, but we don't really need them that much for learning. So let's have a look at what we can do in Python and on Google Colab. So Google Colab, let's just type in some Python code, and here I've just typed in some Python code where we set a few variables. So I've set a weight w1, a bias, and an x1, and they're just variables, so I could have called them anything. And then I've put in a formula, y equals w1 times x1 plus the bias, and then I want to display the output. And we can run this in Google Colab by pressing the play button, or you can see I can also type Control Enter. So I press that, and it'll come up with 17 as the answer. If you are using just straight Python, you'd have to put a print statement around the y, say a print function, say print in brackets y, to print out the 17. But we're using interactive Python, which has got pretty much everything that Python's got, plus a few extra things to make it work in an interactive environment. Now this function that we created there, we've just typed it out straight. We could put it into a function here that we can then call. So let's call the function myAlgorithm, and we can call it, so myAlgorithm on the value 3 gives us 24, myAlgorithm on the value 4 gives us 31. So you can see there's 2, 3, 4, 17, 24, 31 are the outputs of that function. Now I'm assuming you're absolute beginner, so you haven't seen Python at all before. we want to use some libraries, and now there are standard Python libraries and there are third-party libraries. These ones, Torch and Torch Vision, are third-party libraries. They're provided by Facebook. Alternatively, you can use TensorFlow, provided by Google. And Google Colab provides these libraries for you already installed, so we can just use them just by putting in an import statement, and then we can use them later on in our Python code. So let's just import those. They're quite big libraries, so it takes a bit of time to import them. So it took a while. Now we can check to see if a graphics processing unit is available. So if you didn't change your runtime, that should come up as false, but we did, so it should come up as true. And now we know that the GPU is available, so we can say we can specify a device to use the GPU because it's available. Now this works really well on Google Colab. I tried it just on a PC, and even though I had a graphics card in the PC, it said that CUDA was available, but when I tried later on to use it, it failed. So if you're trying to run this on your PC rather than in Google Colab, then the next line you might want to just say Torch device is CPU. But if you want to try the code as it is, it'll try to detect the GPU, and if so, it'll use it by setting the device to CUDA. Let's run that. Alright, so I've now set the device as CUDA. Now the pre-trained models, we're going to use, there's a couple in the models library that we imported from Torch Vision. And the first one we use is ResNet 50, and it's a pretty well-known one. It was released in 2015. It was a 50-layer neural network, so that's why it's called ResNet 50. And it was trained on more than 1 million images. So let's use that one. All the weights have been stored in here. So this is the pre-trained model. So I've just put PT weights for pre-trained weights. And then we've got the model. Is ResNet 50, and I can apply these weights, the pre-trained ones. So you could use your own weights if you've done some more training on it, but we're going to use the pre-trained ones. And then I've said, and I want to put it to the graphics processing unit. So this is downloaded all those weights and created our model. Now we tell the model that we're going to be using this in evaluation mode. We're not in training mode, we're going to be in evaluation, so we say PT model eval, and it knows then that we're going to be in evaluation mode. So I wanted to get a picture of a snake, and so I did a bit of search on the net, and I found this news story on the ABC. It's about a little dog that was attacked by a snake, and so I found the image for this snake, and that's the one I'm going to use to see if our pre-trained model can identify what sort of snake it is. So I looked at the code behind it, found the URL for that code is on this ABC Content Delivery Network URL. So let's have a look at the full picture. So I'm just using the Python image library here and URL libs standard library to download the picture into a file called snake.jpg, and that's the picture. So we're going to work out what sort of snake it is. And you see by running this little few lines of code here, it's saved a file called snake.jpg. So if I look in files over here, you'll see snake.jpg has been downloaded into my Google Colab area. Google Colab will delete all those images when you've finished with it, so don't store anything there that you want to keep. But we can always get this one again later because it's just available on the ABC. So that's our image. And now let's try to use that in our model. Now the model is being trained on a particular size of images, and they were all 224 by 224 pixels, and the looking at the way the colors were in it, had a mean and standard deviation of, and these values are what they're there. So to use our image in this pre-trained model, we need to make sure it's normalized the same way. So we're going to resize the image to 256 by 256. Then we're going to crop it to 224 by 224. And these are the same transformations that are applied to all the images that are in this 1 million images from ResNet. We're then going to convert it to a tensor, and once it's in a tensor, then we are going to normalize it using those means and standard deviations. Now, you used to have to know all these values, but fortunately the Torch Vision model now actually provides them with the weights, so we can just say with the weights, tell me what all the transforms are and store them into this variable here, and we can then use that on our image. So this is how you do that. Import torch. We probably don't need to do that. I think we do that at the top. Snake 224 equals transform. So we take the PIL image that we downloaded from from a JPEG, and we transform it into our variable snake 224, and then we unsqueeze it and we store it on our GPU ready to be have calculations done. So if I look at what snake 224 is, I didn't get the transform. I've got to run that cell first, and then I can run this one. And snake 224, it tells me it's got a size of 3 by 224 by 224, so that's the width and height of the image in pixels, and this is the number of colors. And then the tensor, it's just unsqueezed that into a tensor, and we've only got one image that we're working on, but we could do more. Because there's only one, then the one is now in our dimensions for our snake tensor. So let's have a look at what the model will see of the image now that we've done those transformations. And I'm going to use the matplotlib library to do that, because it can take that tensor from snake 224 and use a permute function and the numpy to then do an image show of that image. So that's what it looks like. Apparently the model is better at identifying the contents of that image if that's what it sees, rather than what we were seeing, which is a different color range. Okay, so Torch is the library. We should say we're not doing any more training, so we can turn off gradients because we're only doing inference of what the model is, of what the image is. So we'll turn that off, and that'll just make it run faster and use less computer power. And we just want to apply that image, the snake as a tensor, into our pre-trained model and get an output. So let's see what that gives us. So we print the shape first of the output. So it gave us a 1 by 1000 matrix of values, and I just look at the first 10 of them, and there they are. And it tells me it's actually on my graphics card that Google have provided us, not the graphics card in my computer. So these numbers are all, they're linked to the probability of the 1000 different classes. So every image in the training data was put into one of these 1,000 classes, and then we've added a new image and said which class best suits it, and it's given us some values like a score of each one. Now we like to convert those to probabilities, and so we use the softmax function on that output of that 1,000 element array of values, and that will give us a value between 0 and 1 of each of these. So it's really just like normalizing all of those values. So we get number between 0 and 1. That gives us a probability of how likely it is that our image is of that class, and then we'll sort it by those probabilities to see which was the most likely. But then we need the names of the classes. Unfortunately, in this case, our pre-trained weights also has some metadata attached, and one of them is categories. So we can use those categories to link the classes to their names. All right, so let's run this. So the top 5 guesses using ImageNet 1K and ResNet 50 with a 31.83% chance of being right, is it's classed it as a rock python. So that's pretty close. It's definitely a python, and it's not actually a rock python, and it's a carpet python in Australia. We used to call them carpet snakes. But that's the most likely one that it's decided out of the. It only had 1,000 to choose from, so it's chosen. All of the top 5 choices are snakes, so it did recognize the image was a snake, so it's pretty good. And it even got quite close with its identification of what sort of snake it is. So did anyone try a different picture and see if they got any reasonable value out of that? So our next exercise is going to be using a different model. So this time we're going to use the ImageNet v2l. So this was a neural network that was released in 2021, a bit more advanced than the ResNet 50. It used high resolution images when it was being trained, and some of the algorithms it used were a bit more advanced because they had 6 more years of research to apply in this case. So to get the weights, we use in models from Torch Vision, we get ImageNet v2l weights, and we can also get our model, and then we can apply those weights into the model and put it onto the graphics process unit. Just as before, we tell the model we're going to be evaluating rather than training. Same way to get the transforms, we just call ptweights.transforms, and we can store that into our function that we can apply, and then we can apply the transform to our high-res snake. So it's going to do the same. It's going to show us what the model is seeing of the snake, so what it looks like, and it'll, this time, well, let's run it and see. So it's got to download that that model, and it'll get all the weights and the categories and things. And we can see that the size is now 3 colors, which is red, green, blue, times 480 times 480, and there it is. Looks even worse. I can hardly see anything there. But using this new model, but on the same 1,000 images, and the same 1,000, sorry, not 1,000 images, 1,000 classes that have been trained on 1 million images, we get still rock python. It's got a bit more confidence this time. 70.84% is that this is the one that's the closest match of all the classes. And then night snake, king snake, boa constrictor, and sidewinder. So there's even a little bit of rearrangement down in these lower ones. But yep, rock python's still the main contender as what this snake really is, which is pretty close. If you look up what a rock python looks like, it does look quite similar to an Australian carpet snake. So I thought we'd try a different image set, one that was based on, I've said 21,000. It's not really images, it's 21,000 classes, not just the 1,000 classes that were here, and trained on a much larger number of images. But this is no longer in Torch Vision. This is in another one that's been created by someone called the Torch Image Model Library, and he's been collecting different models from around the place, and so I thought I'd try this one, the VIT base patch 16 _224.org in 21,000K. So the ImageNet 21,000K, 21K classes, I should call that classes, not just the 1,000 classes that we had before. But this image library stores the different weights and the different transforms in a different way to the way Torch Vision does. So I've laid out here how to use it. PT model eval is the same, so that's good. Our configuration, we get that, and then using that configuration we can create the transform. So let's create our transform. Name error, I've got to make sure I run every one of these cells because they all depend on each other. So I'll import Tim first, and then we'll run this one. So I've got to use a warning about my not having a hugging face token. I don't need to. I don't need to set HF token. So I've just left it like that. But it sounds like sometime in the future they're going to tighten things up a bit. Alright, so let's do what we did before. We'll transform our snake. We'll have a look at what size it is, and then we'll look at the probabilities that come out of it, of using it to infer which is the most likely class for this image. So we can see this one was based on 224 by 224 size images, which is the same as ResNet 50, but the second one we used had 480 by 480. These are the probabilities of each of the classes. So class number 1201 is 34% likely to be correct. Class number 1202 is 22.37% likely to be correct, and so on. Unfortunately, we don't know the names of these classes here, and oddly they don't come with the model, so we have to find them from somewhere else. So I found them in people discussing ImageNet 21K. What were the 21,000 classes that ImageNet 21K is based on? And so let's run that. So I go to that URL and I've just pulled down a text file, and I just split them up in lines, and it just put them in order. So these are just examples of the first 10 out of the 21,000. When I look at the top, the highest probability one, the answer is Python. So let's look at the top 5, which we calculated before, and this time we've got names for them. So the top 5, we've got 1201 is actually 34.919%, and it is in fact Python. So that's correct. 1202 is 22.37%, and they've called that carpet snake. In Australia we probably call it, these days call it carpet python. We used to call it carpet snake, but it is a Python variegatus. So both of them are right. It is a python, and it is a carpet python. So It's just odd that they've got a class where something's a general class and then they've got subclasses just linked beside it. But anyway, that's how you can use a pre-trained model to identify your images. So let me know if you've managed to identify any of your own images and use the machine learning models to work out what they are. So that's going to be it for today. In a fortnight's time, I'm going to be doing a Python code on how to run a Django app so how to write your own web application that will link to Strava and pull data down from Strava. So I did an initial version for that a couple of weeks ago. That was pretty heavy going. It was showing how to use Strava authentication for your web app. The next one will be a bit more relaxed pace, and we'll continue on from where we left off. This one just shows you how to use tokens and the API to get that Strava data from your own Strava model, and how to save users tokens so that you can pull down their Strava activities as well. So it should be a lot of fun. No questions so far. I hope you enjoyed the session, and I will see you in 2 weeks' time.